in this subsection, we'll see how the last term expression of an arithmetic progression can be used to deduce the number of terms that you will find in an AP. Let's see an example. Question 1. Find the following sequence, or given that the following sequence has got the first 3 terms and the last term, that is 3x, 7x, 11x, up to 43x. Find the number of terms. In this part, we still move on with the ideas that we've gathered from the very first part of AP to now. For now, we're going to look at, in the example, like the question that was posed, we're going to see how that last term, the use of the last term and its connection to the finding terms within an AP works. That's essentially what this question that has just been shown you seeks to test. So the problem says that a sequence has been given, and the first 3 terms of the sequence are there plus its last term. For purposes of emphasis, let's just re-quote it here. We are saying that the sequence is 3x, 7x, 11x, and it keeps on like that. And the last term is giving us 43x. Okay? This is what the question is saying. And we are saying that these are the first 3 terms and the last term is 43x. The question is, let's find the number of terms. Let's find the number of terms. Remember, anytime you are given an AP or you come across an AP in an exam where the last term is stated, that this is the last term, it should be an automatic prompt that the relation that we quoted earlier by saying that the last term L is equal to A plus N minus 1D has to be used. Always remember that. The last term, then you always have to go to that. So we know that for the last term of an AP, our L, which ordinarily would have been Tn, but for it being the last term we write as L, will be A plus N minus 1D. A plus N minus 1D. There's the last term. In an event where we use the last term L, remember we are saying that the N then becomes the number of terms that is found within the AP. So in this problem, the last term is 43x, and hence the N, when we're able to resolve it, will give us the number of terms in the AP. All right, so let's just move on. We are going to have 43x is equal to A, which is 3x plus N minus 1. Then our D, our common difference, is going to be 4x. Okay, because 7 minus 3 is going to give you 4. So let's just try and simplify that. We're going to have this will go here. That's going to give you 40x. Then you have 4x into bracket n minus 1. Okay, when you're able to deal with that, then we are going to have 10 is equal to n minus 1. And that implies our n is 11. So this AP that starts from 3x, goes to 7x, 11x, and ends at 43x has got 11 terms. That is what this part wants to tell us. Okay? Yes, so you have your value there, 11 terms. Question 2. An arithmetic sequence 4, 11, 18 in continuation has 15 terms. Find the last term. Now this question also has the same connection with the last term effect. That's essentially what it says. It says that an arithmetic sequence, an AP, is of the form 4, 11, 18. And the question tells us that it has 15 terms. 15 terms. The AP has 15 terms. And the question says that we should find the last term. We should find the last term of the AP, which has 15 terms. Remember, we are not saying that the last term is 15. Watch it. They're not saying the last term is 15. It has 15 terms. Okay, so we know that the last term, the question says that we should find the last term, which will also be Tn, will be A plus N minus 1D. This is the same as the last term L being equal to A plus n minus 1d. You can just write L, just that you don't get a bit confused, but you can still maintain it with the Tn. So it's a very pretty simple example. Let's just put in all the values in there. Our L will be 4 plus n minus 1, 15. So that's going to give you 14, because 15 minus 1 is 14. Okay? Then our common difference, as you can see, it will be 7. Okay? So that's going to give you 4 plus 14 times 7 is 98. And our last term will be 102. So this AP that has got 15 terms has its last term being 102.